we're going to end this first day of week 6 talking about muscle velocity and force production. I recognize that I might have already said on the last video that there was only going to be 3, but we're actually going to do 4 this time because I've decided to add a couple of other things. So we've got 2 outcomes here, and we're just looking at velocity and force production and velocity and muscle length. Now, we've talked about this already, but I want to recap here. So there's a relationship between force and velocity. Okay, so notice that we produce the greatest amount of force over here at the lowest velocity. So velocity is 0, force is greatest. This is an isometric contraction. Whereas over here, we've got really no force, but we're able to move really fast. Okay, and so just think about doing a bicep curl without anything in your arms. Okay, as opposed to a bicep curl where you've got 100 pounds. Okay, you're going to be able to move a lot faster without any force. Okay, and so taking this into account, now it's important to know that the axes are flipped here. So we've got velocity this time on the x-axis and force on the y-axis. If we take muscles and everything else is equal, if I've got a larger or a muscle with greater cross-sectional area, it's going to be able to produce greater force than one that has a small cross-sectional area, right? So each of those fibers will generate a specific amount of force, and the more fibers we can get packed in, the more force that they can produce, okay? And so it doesn't really change the velocity, it just changes the force production. But for a given velocity, there's more force produced in a muscle with a large cross-sectional area. Okay, now we can also look at this in terms of length of the muscle and the force production. Okay, and so again, all other things being equal, if we've got long muscle fibers, they'll be able to produce force over a greater length. That makes sense, that if I've got something that's longer than something, than another fiber that's shorter, we're going to be able to have a wider range of lengths at which we're generating force. Okay. And then we can look at this in terms of force production, again on the y-axis, and velocity, that long muscle fibers are going to be able to generate greater velocities for a specific force, right? And they're also going to be able to generate higher velocities, okay? Because they're going to have a greater range because those fibers are long as opposed to short. All right, we can look at this as well in terms of eccentric and concentric. Now, we've already seen this figure before. Now, notice that when we're producing force at isometric, okay, so remember, concentric, we're shortening the muscle. Isometric, there's no change in the length of the muscle. And then eccentric, we're actually lengthening the muscle. This force curve states that the force the muscle can create decreases with increasing velocity of shortening. Okay, so we're looking at the velocity of shortening. Okay, and so but conversely, the force that the muscle can resist increases with increasing velocity of lengthening. Okay, so this is an eccentric contraction. So when we're talking about velocity from these past slides, we're generally talking about the muscle shortening, the velocity of shortening. Okay, but we can produce more force, or we can resist more force during an eccentric contraction. Okay, so remember, concentric, we're producing force. Eccentric, we are reducing force. And with that, we'll end this video.